Kia ora Year 12 and Year 13. In this video I'm going through the first 3 questions in our second batch of practice questions for the Trig internal. So even more than usual, make sure that you've actually had a go at these questions before I go through them. You can pause the video and then try them, or do them all first. So these questions are ones where we have to find the general solutions of the following equations. I'm not going to bother going on to find particular solutions in a given domain. And in each of these examples you have to use identities. And the 2 lots of identities focused on here are the double angle identities and the Pythagoras identity. So the Pythagoras identity is this one here. This comes up in all kinds of places. And then the compound angle identities here, the double angle identities, are sine 2x and cos of 2x. Now there's only one version of this, which is 2 sine x cos x, but for cos of 2x there are 3 different ones. We'll come to those when we get into the questions. Okay, so the first thing to notice, I'm going to start with question 1a, is that we've got an x over 2 in here, and that doesn't feel so good. So here we've got cos squared of x over 2, and here we've got cos of x. It's much nicer to work with an obvious double angle. So I'm going to change this into u. So we start with this, but we'll let u equal x over 2. So we're going to get rid of this and replace it with u. We're going to get rid of the x and replace it with 2u. Once we've got that, we get down to here. And it's really obvious to see that the next step will be to use a double angle. So which one are we going to choose? Well, for cos of 2x or cos of 2u, we've got 3 choices. The first one, to be used in desperate situations, is this one. That's going to give me both cosines and sines. Now sometimes that's what we need, but not that often. The next one is 1 minus 2 sine squared u, and the next one is 2 cos squared u minus 1. So look at what we've got here. Over on this side we've already got a cos squared u, so let's try doing the third substitution into here. That'll give me cos squared of u is equal to 4 times 2 cos squared u, take away 1, take away 1. Cleaning up, we get cos squared of u is equal to 8 cos squared u minus 4 minus 1, which gives me minus 5. And now I'm going to collect up terms. So we have 5 is equal to 7 cos squared u, or cos squared u is equal to 5/7. To get back to just the cosine of u, we need to take both the positive and negative square root of 5/7. And now it's time to substitute back for u, so replace that back with x over 2, and we get cos of x over 2 is equal to positive or negative 0.845154. We're going to work each of these through to get 2 different general solutions equations. So first let's work with this one. Cos of x on 2 is equal to 0.845154. Alpha is the angle whose cosine is that. So that gives me 0.5639. We can now take this and pop it into our general solution formula. So x over 2 is equal to 2n pi plus or minus alpha. So if you're not comfortable with this, go watch the video I've done, or lots of other people have done, on general solutions. The last step here is to multiply everything through by 2, because we want an answer for x. So it'll be x equals 4n pi plus or minus 1.1279. So let's look at why that makes sense. Well, our usual cosine thing has got a period of 2 pi. Right, so this is my ordinary cosine curve. One full cycle takes 2 pi. But when I'm dealing with x over 2, the period of that function is going to be 4 pi. So you can see that coming through in my answers here. So that's the first half of that one done. Let's do the same thing on the other side. Here we get negative point. So we're starting with the negative branch. So alpha will be 2.5777. So x on 2 is equal to 2n pi plus or minus that. And as before, we get x equals 4n pi plus or minus 5.1553. Okay, now if we were asked to go on and find all of the values between, say, 0 and 4 pi, we'd start substituting in values for n. But we're not going to do that here. Let's look at the next one. Alright, so the next one is kind of similar, but it's got sine in it this time. So we've got cos squared of x on 2 here, and we've got 4 sine x. So we can see again that we're probably going to want a double angle formula. Let's go on to a new page. Right, so let u equal x on 2, so 2u is equal to x. That gives me cos squared of u is equal to 4 sine 2u plus 1. So in this case, there's only one thing to do here, which is to replace this with 2 sine u cos u. So it's 4 times 2 sine u cos u plus 1. So cos squared of u is equal to 8 sine u cos u plus 1. So we're solving an equation. We're probably going to have two factors here somehow. So let's make everything equal to 0 by subtracting all of this from both sides. And then we'll see what to do next. So we've done the obvious first step, which is that double angle. So we've got cos squared u minus 8 sine u cos u minus 1 equals 0. So if we want to factorize here, this minus 1 is not very good for us. The best way usually to get rid of a takeaway 1 is using the double angle formula. Because if we add 1, if we could somehow do this, then this would go away with this. But that's not going to work in this question, because we don't have a double angle thing left to do. This middle term here is kind of got sines and cosines in it. So you should be suspecting that you want to end up with something that might have a sine in it. So that's one way to go. This has got no obvious simplification, right? So we could change this to 1 minus sine squared of u, but that doesn't really help us. Maybe it does. Let's have a look. Okay, I'm going to do it a different way first, then I'm actually going to come back and do it that way, because I've just realised that does work too. Here, I'm going to take this 1, and I'm going to replace it with cos squared u plus sine squared u. So if you're watching this video from me for the first time, you'll know that you won't know that quite often I'll do things in a couple of different ways. Just to show you that with trig, you'll often get to the same point. So we've used the Pythagoras identity there. Now what does that give me? Well, that's quite good, because now I've got minus 8 sine u cos u minus sine squared u is equal to 0. I can factorise out negative sine u, and I get 8 cos u is the factor here, plus sine of u. Now it's worth checking back that I haven't made a mistake here, so let's carefully expand out. So we've got negative 8 sine u cos u minus sine squared u, so that's looking good. That means that either sine u is equal to 0, or 8 cos u is equal to negative sine u. So this one is ready to go for general solutions. So alpha is equal to the angle whose sine is 0, which is just 0. Right, let's think about our sine curve. Here we are. So for this one, u is equal to n pi plus negative 1 to the power of n times 0. It's time to get rid of u and put in x over 2. So x over 2 is equal to n pi. This is just plus 0, so x is equal to 2n pi. Now what about here? Well, we can turn this into tan. So negative 8 is equal to sine u over cosine of u. Tan of, replacing it now back with x on 2, tan of x divided by 2 is equal to negative 8. Doing general solutions here gives me alpha is equal to tan inverse of negative 8, which equals negative 1.446. Now you can visualize that. Here's your tan curve here. So negative 8 is getting very negative, right? So we're down here somewhere. So that makes sense. Right, so that's the first part of the tan general solution. Now we're going to have x over 2 is equal to n pi plus negative 1.446. That gives me the final answer of x equals 2n pi minus 2.8929. So these two give me the general solutions. So let's have a look at what that looks like graphically. So going all the way back up, how can we draw this and see what's going on? Well, if I use GeoGebra, I can take the left-hand side as one function of x and draw it. And then I can take the right-hand side and draw that one. And I'm looking for where they intersect. And this is what it looks like. Okay, so we've got two functions here. You can see the green one is cos squared of x on 2. Now, that makes sense because this left-hand side can never be negative because it's a square. You can see the lowest possible value is at 0 and the highest is at 1. And then the blue line is 4 sine x plus 1. So let's look at where these crossover points are. Well, you can see that they are indeed on all of the multiples of 2 pi. And then there's another one which is here. Let's see the next one here. There's another one here, and so on. So you could do some checking to see that those values match up, but they do. Okay, so I haven't got time, I don't think, to get through part C. I'll do a separate video for that one. So go and have a go at that. It looks much worse, but it's really the same skills again. Thanks for watching, and if I've made any mistakes, just leave me a comment or send me an email.